Hello students. Hello and welcome to this video. In this video, we will solve question number 41 to 50 of binomial theorems, multinomials and expansions. So all these questions will be of binomials only. The link to download the PDF will be in description, as well as at the end, I will show you how we can download and maintain updated copy of the PDF. Also, I will show you the question answer website which I have developed for you, and how we can ask questions. You'll see it then. So without further ado, let's get started. Question 41 says that find the general and middle term of the expansion x upon y plus y upon x raised to the power 2n plus 1, and being a positive integer, so that there is no term free of x and y. So the general term PR is given by 2n plus 1 CR minus 1 x upon y raised to the power 2n plus 1 minus r times y upon x raised to the power r minus 1. Since there will be 2n plus 2 terms, there will be two middle terms, n plus 1th and n plus 2th. Now, since the powers of x are symmetric, if any term has to be free of x and y, then it has to be middle terms. So we compute n plus 1, Tn plus 1, and we substitute r is equal to n plus 1 here. And we get 2n plus 1 Cn x upon y. And n plus 2 is 2n plus 1 C n plus 1 y upon x. Now, as we see, this x upon y and y upon x are symmetric. But neither Pn plus 1 nor Pn plus 2 are free of x and y, so there is no term free of x, y. The other way to prove this is that we take the power of x and y. So you can take any power, okay? So, for example, we take the power of x here, okay? Power of y will be negative of that, as you can see from the expression. So it would be 2n plus 2 minus r minus 1 for the rth term. There should be symbol is equal to 0. This should be 0 for it to be independent of x and y. Okay, we subtract this as well, and has to be subtracted. Now, once we do that, we find that r is equal to 2n plus 1 upon 2, which cannot be integer, so no term is free of x and y. Question 42 says that so that the middle term in the expansion of x minus 1 upon x raised to the power 2n is 1 times 3 times 5 up to 2n minus 1 upon n factorial times minus 2 upon to the power n. So there will be 2n plus 1 terms in the expansion, x minus 1 upon x raised to the power 2n. So middle term will be 2n plus n plus 1th term. So we find tn plus 1. So we get x raised to the power 2n plus 1 minus n minus 1 and a minus 1 to the power n x to the power n. So this is equal to minus 1 to the power 2n factorial by n factorial times n factorial, which is equal to 1.3.5 times up to 2n minus 1 divided by n factorial times minus 2 raised to the power n. Question 43 says that if in the expansion of 1 plus x raised to the power 43, the coefficient of 2r plus 1th term is equal to the coefficient of r plus 2th term, then find r. So here we take the term t2r plus 1, and the term would be 43c2r x raised to the power 2r. And tr plus 2 is 43cr plus 1 x raised to the power r plus 1. Now, given that coefficients are equal, so 43c2r is equal to 43cr plus 1. This 3 is a term, it should be 43. Once we have that, we know that 2r plus r plus 1 is equal to 43, so r is equal to 14. Question 44 says that if the rth term in the expansion of 1 plus x raised to the power 20 has coefficient equal to the r plus 4x term, then find r. So, rth term in the expansion is given by 20cr minus 1. This 0 is again at the wrong place, and the coefficient of r plus 4x term is 20cr plus 3. So again, like question 43, we substitute r minus 1 plus r plus 3 is equal to 20, so r is equal to 9. Question 45 says that if the coefficient of 2r plus 4x term and r minus 2x term in the expansion of 1 plus x raised to the power 18 are equal, find r. So we proceed like previous problem. So you subtract 1 from both this and add it to be equal to this power. Okay, and that is equal to 18. So I is equal to 6. 46 is also similar. We are given that quotient of 2r plus 6 and r minus 6 term are equal. So we have to find r is equal, and the expansion is 1 plus x equals 39. So here we get 2r plus 4 plus r minus 7 is equal to 39. So r is equal to 14. So RC 12 is equal to 91. Question 47 says that given positive integers are greater than 1 and greater than 2, n being even and quotient of 3 rx term and r plus dx term in the expansion of 1 plus x to the power 2m are equal, find r. So here 3r minus 1 plus r plus 1 is equal to 2m. That is r is equal to n upon 2. Question 48 says that if the quotient of p plus 1x term in the expansion of 1 plus x to the power 2n be equal to that of p plus 3x term, show that p is equal to n minus 1. So here we take the power, the p plus 1x term will give 3 and p plus 3x term will give p plus 2, which is equal to 2n. So p is equal to n minus 1. Question 49 says that show that the quotient of r plus 1x term in the expansion of 1 plus x to the power n plus 1 is equal to the sum of quotient of the rx and r plus 1x term in the expansion of 1 plus x to the power n. So quotient of r plus 1x term in the expansion of 1 plus x to the power n plus 1 is n plus 1 CR. Quotient of rx and r plus 1x term in the expansion of 1 plus x to the power n are NCR minus 1 and NCR. Now we know that sum of these two is equal to this, and hence we have proved this. Question 50 says that find the greatest term in the expansion of 7 minus 10 upon 3 to the power 11. So since we have the term has to be numerically greatest term, we replace minus sign with plus. Let rth term be the greatest term in the expansion. So PR is equal to 11CR minus 1, 7 to the power 12 minus R, 10 upon 3 to the power R minus 1. We consider R plus 1x term. So that is 11CR, 7 to the power 11 minus R, times 10 upon 3 to the power r. Now it is given that TR is greatest term, so TR upon r plus 1, that is 21r upon 12r minus 10 will be greater than equal to 1. That is r will be greater than equal to 3 and 3 plus 27 upon 31. I don't know a better way to read that. Now we replace r with r minus 1, so TR minus 1 would be less than TR. So we get 21r minus 21 upon 130 minus 10r. That is r less than 4 plus 27 upon 31. If somebody can help me how do you read this in English, I'll be much grateful. So from these two relationships, we see that I is equal to 4. So the greatest term will be 11 feet 3, 7 to the power 8, 10 cube upon 3 cube. That is 440 upon 9, 7 to the power 8, 5 to the power 3. And with this, we come to the end of this problem set, and let me show you the website. So you come to astrologer.org and you can download algebra, trigonometry and coordinate geometry books from second, third and fourth links. Note that the downloaded PDF will not have the date, so you need to add date when you download, and after 15 or 30 days you come back here and see whether the date has changed. Okay, and if the date has changed, then you can download again. I cannot put the date in the link because that will invalidate all the existing links. Also, if you want to ask questions to me, math questions, you can click on its link and come here, and you can ask questions here, and you can create a login. We have tags for math, algebra, calculus, geometry, coordinate geometry, mathematics, probability, trigonometry. So you can use these tags and ask questions. So this website has been developed specifically for you, and I will show you in few days how we can add math. It is possible to use LaTeX math, but most probably you don't know LaTeX if you are a class 12 student. So I will prepare a comprehensive tutorial for math typing. Okay. So with this, I will end this video. I hope that you are enjoying this series of binomial theorems and entire algebra playlist in general. So thanks a lot for watching the video. I'll see you tomorrow in the next video with 10 more problems. Keep learning, have a great day, and most importantly, enjoy.